Rata. All humble request to each one of you, and it would encourage us if more and more people joins this right kind of programs. So Pritesh bhai, thank you so much for making me part of this program. Over to you. You can talk about Rata and kickstart with the program. Thank you very much.
Thank you,
humble request to everyone. Please mute your audio unnecessary because it breaks the flow for the speaker to speak. Thank you very much.
Thank you, Mirwai. Dear fellow members of HVC Trade, I, Pritesh Shah, Secretary of RRC Mumbai, welcome you all. Ours is a team of 20 passionate, like-minded people. 20% like-minded people who work for the betterment of HVAC industry. We are having nearly 300 companies as our family relationship members. They are which consist of traders, manufacturers, SSD dealers, consultants, service providers. We RRC Mumbai, we call it as a relationship, not a membership. We are having our flagship program as a Vyapar Summit. In last 8 edition, in the last month only, we were able to generate the lead of 40 million rupees just among our participants. Friends, join RRC family, and I assure you this network will be a net worth. This is not a network, it's a net worth. Over to Manish bhai to start the program, please. Thank you.
Thank you, Pritesh bhai. Thank you once again. I welcome each and every dignitary over here, also all the speakers. I will introduce now to Mr. Sumant Mathur. In fact, Sumant actually is very well-known name in soldering as well as brazing industry, but still formally I will introduce him. So Mr. Sumant is a postgraduate research fellow from UK with MPhil in metallurgy of diffusion bonding. He has designed numerous brazing and soldering alloys and is the pioneer of brazing consumables in India. He is running his own company by the name of Mathur Metals Works Private Limited, and amongst the first ones to start ROHS, REACH and non-CFC compliant fluxes and brazing alloys. Currently, Mathur Metal Works manufactures around 75 types of alloys, 30 different types of fluxes, and still focus on research and development of new alloys and fluxes for various applications. So this actually you can see how passionate Mr. Sumant is basically in welding as well as brazing. He is training actually a lot of people across the globe. His presence actually is in UK, Sri Lanka, Nigeria, Turkey, Thailand, UAE and USA. He has trained up till now 20,000 operators. He has also achieved a lot of national as well as international awards. He never shies away sharing the knowledge. So this is what Mr. Sumant Mathur is. So without wasting much time, I will hand over the baton to Mr. Sumant Mathur. So Sumant, the forum is all for you now.
Yes. Thank you, Manishji. Actually, I am lucky to have a good panel of experts in this particular program, and I would first like to introduce them. I'll start with the youngest, Mr. Gabriel Benardi. He is the graduate business administration from Tecumseh University, Tennessee, USA. Currently pursuing his MBA in strategic leadership at the University of Cumberlands, Kentucky, USA. Currently living in Cincinnati, Ohio, working for Harris headquarters for almost 3 years as an international technical sales representative. He had gone through an immersion of 6 months of technical training about the gas equipment and brazing application. Furthermore, he has completed his welding training at the Lincoln Electrical Welding Technology, which is one of the oldest training center in the world. And he has experience in the welding, brazing, and oxy-fuel cutting industry, and currently manages accounts in the USA. USA, Germany, Poland, India, Bangladesh, Philippines, China, and Brazil. In addition to the sales role, he provides technical support to international customer services located at Harris headquarters. Our second panelist is Mr. Richard He is working for Uniware. Uniware was actually established in 1949, and he is with Uniware for more than 25 years. He has a great experience of almost 30 years in the field of welding and brazing, and they are manufacturing the products for Uniware, which are support to the brazing industry normally. And he is the director of international sales. So I welcome Richard. I welcome Gabriel also. And third one is Dr. Manish Saman. He is basically MSc Inorganic from Mumbai University, 1990. He is a PhD. He is a doctor in chemistry, and he has done his PhD in BARC in 1994. After that, he went to Wellington University Institute for Management, and then he done some work on brazing, and then he went to France. He was there for quite a number of years. He has 27 years of experience in the development of various welding and brazing consumables. And he is also a life member of Indian Institute of Welding. So I welcome Dr. Manish ji. And for two other guests, I will request Prakash Shekhani to please introduce them.
Yeah, so I think Mani, this Sumantaji, Arun's introduction, I think you need to do it because I don't have this thing with me. It was not shared with me.
Sumanji.
Yes. 1 minute, please. Arun is basically working with Uniware, and Arun has got also a vast experience in Uniware. He is looking after the India sales. He is basically helping them to develop the clientele in the field of brazing, and Uniware has got a large number of clientele in Asia and South Pacific Asia. And Arunji is looking after that, the entire business of Uniware in representing in India. So I welcome Arunji also. Anyone?
Yeah, I think you can continue, Sumanta. You have the introduction for everybody, right? Prabhav also you can introduce.
Yeah, I don't have it for Prabhav, so if you can introduce him.
Yeah, so Prabhav is a business graduate from University of Glasgow, and he has been trained at Harris for the technical sales program for 6 months and at the US, and another 3 months in Poland for the gas equipment. And he has been working on passionately on this brazing and gas equipment business for last 5 years. Yeah.
Okay, just to now give you the basic gist of how we are going to go about it. I have the presentation of all the presenters here. Basically, our topic of today is brazing without oxygen, which everybody knows it is not a possible, and we require oxygen at some extent, but we are trying to see what are the basic things we can do. So in order to save the time in transfer of transferences from, or the presentation from one to another, I will be doing the entire presentation. I will do presentation of my slides, followed by the other eminent speakers. So they will speak, however, I will be changing the slides. So in between, you will hear the voice, next slide, please. So please bear with that. But I will request you all to listen and learn and write down your questions, and we'll be very happy to answer the questions. We are not going to touch upon the basic things in brazing simply because you all are working in the brazing and you all know what is brazing basically. And for last couple of months, I think you have experienced the whole problem, which is having to do brazing without oxygen. So basically in my slides as well as in future slides, we have covering the alternatives and the consequences of doing it without oxygen. So that will be the basic, the whole idea of the this particular presentation. I will be now sharing my screen.
It's okay.
Always the basic question, is it visible? Because from my end, I will not know. Can you all see the?
Yes, yes.
Yes, sir.
sir. Yes,
Yeah,
sir.
please
it is
proceed.
visible.
Okay. I will just go through this
Yes, sir.
slide and explain what I want to say. And then after that, I will pass on to the next speaker after I finish my slides. There are some videos embedded, but we just found out in the beginning of this session that some of the videos are taking a lot of time to play. So we may probably avoid playing the videos and we'll skip those parts. But those videos will be available on the YouTube, or we can make it available if anybody is interested, especially to see the videos, in order to, as a educating videos, to learn from the videos. Okay. Now, basically what we are talking about is brazing without oxygen. Now, who requires the oxygen? If you think of the brazing, there are basically, we are talking about the temperatures between 450 degrees centigrade to 1100 degrees centigrade. And there are various methods are coming in between. So if we just go through the methods of brazing, where the method of brazing is the method of heating, basically, that's what we give the name. So if you do a heating using induction, we call that as the induction brazing. So if you take those methods, then there are n number of methods. Out of that, I have mentioned 10 here. Induction brazing, where you don't require oxygen. It is basically the induction machines which are giving the current and you're doing the brazing. Then there is a resistance brazing. There is a furnace or electrical oven brazing, or atmosphere and vacuum type of brazing. Then there is a deep brazing, like your cycles they are doing the deep brazing, where the cycle, the V shape is entirely dipped into the copper zinc bath, and the brazing is done, like same as a deep soldering. Then there is the ultrasound brazing. Then there is a laser arc brazing, or arc brazing, or electron beam brazing. Then there is a twin carbon brazing. Then there is a MIG and TIG brazing, where they use the brazing wire rather than using the copper coated MS wire. Then there is the infrared brazing, which is done at little lower temperature. And then we are talking about a torch brazing. So 1/10 of this, if you just go divide in that way, then the 1/10 of the brazing is for the torch brazing. So there are very small sector which uses oxygen. Now within the torch brazing, there are again 3 types of brazing. One is the oxy fuel brazing, where oxygen is used and the fuel is used. Fuel can be anything, like your propane may be there, or acetylene may be there, or your LPG would be there, or MAPP would be there, so kind of things. Then there is the air and fuel, where air is used instead of oxygen. Air can be in the form of compressed air, or air can be in the form of just the air, which is taking a pressure from the fuel gas and then getting sucked into it, and then the torch is burned. So that is the air fuel. And the third is HOH. HOH is not a very new technology. It is old, almost 25 to 30 years old technology. In our chemistry also, we have seen that if we take a water, add some salt or something, give a current, your H and OH get separated, or H and O get separated, and you can, if it goes fut, then there is a hydrogen, and if it burns, then there is oxygen. So you can get a cation and anion reaction where H and OH get separated. Now this same H and O is get collected under pressure, and then it passes through the torch and it is burning. So that is known as the HOH burning, where air is not, I mean, the oxygen or fuel is not used, but only the water is used. So these are the three basic types of torch brazing techniques. Now, if we touch upon this, since our topic is basically on the brazing without oxygen, we are basically concerned with the torch brazing. So if you consider this area, then in torch brazing, I have simply, basically, I have just mentioned that this is a combination of air, oxygen with air, or fuel inside the torch burning at the exit of the nozzle. Hence, the torch brazing without oxygen is not possible. Oxygen is required at some end. However, we can use air, or we can separate oxygen from air, or we can electrically separate the water to form H and OH combination. This kind of torches, they are known as a hydro torch or aqua torch. So the first one, where there is a oxygen and fuel composition, the gases are used are normally acetylene, propylene, natural gas, or MAPP, which is methyl acetylene or propylene gas. Then propylene gas, LPG is again mixture of propane, butane, and propane, etc. So these are the basically gases used. Here, actually, I had a video, but since it is not playing, I don't want to play it now and waste the time. Second is a air fuel. Most of our today's guests here, they will be talking about this kind of torches. So I will not talk much on these torches because there's a lot of information they can share with you on this particular in this particular area, where the design is also there and some other areas also there. So basically, it is a torch which is combined with air and fuel, and the fuel can be LPG or natural gas or dissolved acetylene from carbide stones or any other hydrocarbon gases. And the air can be in the form of compressed air, or it can be without compressor. Normally, there are methods of even getting oxygen from the generator, and there you can get oxygen up to 92%, 95% concentration. You may also be able to see some of the videos on air where they're showing that they are using the concentrators and they are doing the brazing using air or using the compressed air. And there is a third type of torch. I said about a torch, which is again using the fuel as a H and OH. So these are the torches where normally the electrical current is given and you can get a hydrogen as cathode and oxygen as anode. And these are then separated and combined into some chamber. It can be pressurized, and the whole thing can be pressurized and brought through one single pipe. And it has the higher calorific value simply because it is forming the single molecule. There is no loss on this, or there is no byproducts. The pollution is less in this kind of things. And these are known as aqua torches or hydro torches. Many people in Europe, in Korea, in America, they are using this particular aqua torches or hydro torches. If you see some of the jewelry industries, they've been using aqua torch as a pencil torch for more than 15-20 years in India. So aqua torch is not very new to India. It is already there for jewelry manufacturers, where the pencil torch is used and which is very common. So this is the third type of torch. Now, what are the requirements? If you just put it as from the user point of view, what are the requirements they want in any kind of brazing? So I've jotted down a few of the requirements and few of the requirements from the torch point of view. This is for the discussion as well as for you to think about it whenever you are deciding on what torch. Number one is you should have a good flame pressure. Your inlet gas pressure should be good. So your torch design is very, very important in this. You should have a flame which will give you high calorific value, because more the calorific value, you will get lesser the time required for the brazing or lesser losses on the gases. Then you should have a full combustion requirement. There should be 100% combustion with the fuel and oxygen. If you don't have a proper combustion, then your area where you are doing a brazing can become poisonous for you, because most of the gases then coming out are carbon dioxide or carbon monoxide. Then you should have a concentrated natural flame. If you have a concentrated neutral flame, if you have a neutral flame, then you will always be able to do a better brazing, because you can then concentrate your efforts on the area where you want to hit. You are not hitting the entire more area. This is known as there is no less flare, And the last one is the less pollution. I told about combustion. So basically the byproducts from combustions are not forming that much. So that is something which is very, very important. Now, when you think of this, what sort of torches we must have? We should have a torch which will give you the fireproof material or fireproof design, or you should have a torch which will not give any kind of backfire. So you should have a torch which is not giving backfire assembly, or the backfire assembly should be there. And the torch should be light and easy to handle. So these are the basically three requirements of the torches. Now, many people, they ask me as a consultant, what is the combustion? What is the ratio we should keep between the oxygen and acetylene, say, for example? So I have given you the reaction here, basically how anybody can learn from this, and it is very easy to understand. If you take 2 molecules of acetylene and 2 molecules of oxygen, the very first primary reaction you get is a 4 of carbon monoxide and 2 of hydrogen. This is normally the reaction, what we call as the primary reaction in the core. So whenever we say a neutral core or the core, what is the core composition? Everybody says the core composition is one molecule of acetylene with the one molecule of oxygen, which is entirely right. But you have to consider the secondary reaction also, which is happening in the flare, which is the 4 of carbon monoxide, 2 of hydrogen, and then you need again 3 of oxygen in order to complete the reaction, forming carbon dioxide and hydrogen H2O, water molecule. And that is a complete reaction because all the products which are made are 100% stable. And this is what is the whole reaction. Now, if you see this reaction, then you have 2 of acetylene molecules requiring 5 of oxygen, which means 1 molecule of acetylene requires 2.5 molecules of oxygen in order to form a complete combustion reaction. So whenever you have this reaction, it means the ratio is again going to be in that form of 1:2.5. So whenever you use air instead of oxygen, your ratio may increase to 1:3 or 1:4 or 1:3.5. I think the other people who are there in the panel, they will explain this maybe better. But this is how your pressure or your composition would change in order to get you the complete combustion reaction. So this is just again, one of the thought which I think we should consider in having a torch without oxygen. And here I'm just suggesting some of the solutions. The very first solution is try to convert the gas brazing joints to the nearest possible heating source. Like we have seen this 10 sources. Out of that, the 10th one was the gas brazing or torch source. So rest 9 sources are available. So if you find that you have a joint or you have a combination of metals where you can use any of the other method of brazing like induction or resistance or something like that, you may be better, you may change to that. That is one alternative you have. So for that, you need to have a joint design, and you may have to have the limitations also for the new heating source. So if that is possible, then you can go for that. The second one choice is that just joints where more heating and time and more flare is acceptable. Like sometimes what happens is when you do a brazing with air and acetylene or air and LPG, you'll find that the flame is not that much concentrated. It has a more flare. So if you want to intend to heat only the 5 millimeter section, but you are going to end up hitting double of that or triple of that section, So if that is possible, like for example, in HVAC joints, it is possible. So if that is the case, then you can go for a LPG or acetylene with air. Now here, one thing I must mention, that if you are heating with acetylene air, the time required is higher as compared to oxygen acetylene, but time required is less as compared to air LPG. So in air LPG, if your time required is say 30 seconds, then air acetylene, it will require 15 seconds, and oxygen acetylene, it will require 8 seconds. So that is normally the time requirement in this torches or this combination. So third option is using a torch where there's a gas, water gas or hydrogen torch or aqua gas torch. Naturally, these particular torches are a little expensive to buy the machine, but your working, when you do the long-term alternative is better because your working cost is very, very less. And the fourth alternative, of course, is have your own oxygen generator. I think many people are doing that kind of thing. So they will have their own oxygen generator. I think this is end of my presentation. I will request Pranav or Gabriel to start their presentation. I will mute myself. Is that okay?
Yes,
Absolutely,
Sumanji.
Mr. Mature.
Yes, Mr.
Thank you
Gabriel,
so
you can
much.
start.
Thank you so much, Mr. Mature, for your presentation. Very informative.
Thanks.
I really like it.
I'm muting myself. You can continue and you can instruct me to go for the next slide.
Sounds good. So you can go to the first slide. Next one, please. Wonderful. So as Mr. Mature was explaining before, when we're talking about brazing, we have many methods, and one of them is torch brazing. When we are talking about torch brazing, we must think about the triangle of fire. And what is the triangle of fire? The triangle of fire explains to us how we get a flame. And the triangle fire, which you can see on the left of the screen, you need a fuel source, oxygen, and an ignition, and then you will have fire. So which means you will have your flame to do your brazing job. In the torching brazing, we have mainly two options on torches. First one is air fuel, which we'll be discussing today. I will give some information about it just because this is the option that we have, that you do not require any oxygen source, which is already in the atmosphere, it's in the air. And the second one is oxyfuel, which is a fuel source and the oxygen source as well. So we can go to the next slide. Perfect. So this slide here is just to show us a difference that we will see when we are doing oxyfuel torch, when we are brazing with an oxyfuel torch and an air fuel torch. So for instance, if you look on the bottom two temperatures on the left side, you see the first one air acetylene, and the second one is oxyacetylene. The air acetylene is an example of a torch that you can see the picture on the right. So you just have the acetylene source as the fuel, and the oxygen is coming from air. I will explain in the next slide how does that work, but you do not have a specific source of oxygen for this type of torch and brazing. When you are using air acetylene, the temperature that you get is more or less 1,400 Celsius degrees. And when you're using an oxyacetylene, you have a better and a hotter flame. We can go to the next slide, please. Perfect. So we can see that there is a wide difference between oxyfuel and air fuel, but and this comes from the source of oxygen. And how does the air fuel torch works? The pictures on the right is a picture of the top picture is the picture of the bottom of an air fuel tip. Air fuel tip will have always an orifice, an open orifice, more than one, which will allow to create a venturi effect. This venturi affecting the tip with the pressure from the fuel gas that is coming in, it will kind of suck the air that it has around it and provides the perfect combustion between oxygen and fuel. So then you'll be able to have a flame. This is one advantage of this, but you can see on the pictures. You can see on the picture that I have on the bottom, like the flame is kind of like a jet engine format. It's kind of like spinning all around, and this is how we call the venturi effect created in the air fuel torches. Can move to the next one. So benefits of an air fuel torch. First of all, you don't need an oxygen source. So here in the US, a lot of contractors, people that go to your house, fix your HVAC or plumbing pipes and things like that, they would rather have most of the time just one cylinder instead of carrying two, oxygen and fuel. They would just carry one. And in today's situation in India, it is also a solution for the ones that used to use oxyfuel torches. It is less equipment required. You do not need to adjust the flame, the flows of the flame on the torch. So when you have an oxyfuel torch, you have to adjust the regulators, the pressure on the regulators according to the tip that you are using, and also the valves on the torches to adjust the flow and everything according to the tip that you are using. So you have a very unique measure basically for each tip that you are using in the job that you are doing. when we are talking about air fuel, for instance, we use for acetylene just 15 psi, which is pounds. I think 5 pounds if I'm not mistaken, but it's just a fixed amount. So it's like always 15 psi. Doesn't matter the flame that you want. If you want a very if you have adjustable torch, if you wanted a lower flame or a hotter flame, you always set at 15 and you'll get your job done. It will automatically do the combustion, 100% good for you, 100% pure heat, and it's a blowout resistant flame. So there are benefits, but at the same time there are some disadvantages, as you always see. The flame is wider. You'll be able to preheat wider places, but if you are trying to do a very specific job, a very unique job that you need to apply the heat in only specific places, you might have some issues ongoing with air fuel. So definitely there are benefits, but it's not the method that you should apply for all of your brazing applications. I think we can move to the next slide. Perfect. So this video, I'm not sure if we'll play well, but perfect.
We are able
So
to see.
this video is a homemade video we did at Harris. Myself and my manager, we recorded this video to show Faith and our partners how air fuel works, and mainly the difference between acetylene and propane air fuel. So you all can see the difference on the left side. We have the propane torch, both at the same pressure settings, open at the maximum level, wide open the valves and everything. But you can see that it takes double the time, as Mr. Masseur was talking about before. He said around 15 seconds on acetylene and 30 seconds on air propane. And this is exactly what we found. It was actually 16 seconds on the acetylene to start melting the alloy, and 30 seconds on the propane. And just the reason behind that, if you look into the combustion rate on air fuel, on a flame for acetylene and propane, when we are talking about acetylene, it is 1.5 to oxygen molecules to 1 of acetylene, and when we're talking about propane, is one propane molecule to 4 or 5, 4 to up to 5 molecules of oxygen. So when we are having an air fuel where you don't have the source of oxygen, you don't have as much oxygen as you have when in the air fuel, when you don't have as much oxygen as you have on an oxy fuel torch, you're kind of like lacking, the tip is missing some of these oxygen molecules. So maybe in the air fuel torch, it's bringing only 3 or 2 molecules of oxygen to the torch. So as you know, our air here at atmosphere is like from 26 to 28% of oxygen. So you don't have pure as when you have an oxygen cylinder using it. So that's the main reason why you will see that acetylene will work way better, hotter, and good for your application on the air fuel torches. Prabhav, anything you would like to add? This is my side basically, which I would like to provide you all.
I think it is better if we take all questions at the end because
Sure. We take the questions at the end.
yeah, because then all of us can answer at that, depending on to whom the question is addressed. Now, may I request Mr. Manish Saman, Dr. Manish Saman, to please continue with his presentation?
Yes. Good
And
evening.
thank you, Gabriel. Thank you very much.
Good evening to all. Thank you, Mr. Mathur, for my brief introduction to all. As you know that in the introduction, Mr. Mathur has quickly listed the various brazing technique that has been used for brazing. And we can say the technique rather than at what Mr. Mathur said, that is basically an heat source, which is required for the brazing. So these are the techniques one can use when the industry is facing a scarcity of oxygen. And in this list, the one technique which is called as torch brazing. So the hydrogen generator is the technique which is among the torch brazing technique. So this hydrogen generator basically is a safe and better brazing flame, which is used by hydrogen and oxygen by electrolysis of water. So to generate an hydrogen oxygen, as Mr. Mathur has rightly said in the beginning, it is not a new technology or thing. It is known by science way back in 1800 century, 1800 year at 1800. So what you need to generate an hydrogen and oxygen, we need water for electric power source, and we have to do the electrolysis. And so we need or may not need the chemicals, because some of the technology or the power hydrogen generators are required made with the pure water, or maybe with little chemicals to be added to initiate the reaction. So these gases, separated gases which are being produced by electrolysis, are being combusted in the brazing torch. And again, with the one manufacturer to other manufacturer, this torch design is different, which leads to produce uniform heat from this flame or from this torch. And this can be an alternative to our conventional oxyacetylene or oxypropane gas systems. This combustion oxyhydrogen gas can reach very high temperature. And as this process is a very environmental friendly, because it produces or almost zero carbon dioxide. So generated flames is specifically suitable for brazing almost all the brazing application. And because of this hydrogen generator, one can get rid of distribution system, then handling of gas cylinders, and most important is the storage of this hazardous gas and the cost to it. So next slide, please. So these hydrogen generators produce a temperature of the flame of around 2700 degrees centigrade. This is the design of the torch is so light in it, so easy to braze, and weight is absolutely light. And you people must be worried, that does the system will take long time to generate this gas once you put on the system. For your information, it takes just 3 to 5 minutes after you switch on the generator. You can start your brazing operations within 5 minutes. These generators have available on AC and DC power source. The voltage requirement can be 110 to 240 volts. These generators are available on single phase as well as 3-phase, depend upon the capacity of production. The power consumption is also depend upon the rate of producing these gases. So it varying from 2 kilowatt per hour to 12 kilowatt. So with 2 kilowatt, we can produce gas at a rate of 300 liters per hour, sorry. As when you reach to 12 kilowatts per hour, then the rate of generation will be 3000 liters per hour. So depend upon the capacity of generator, the gas produced will be different. And the thing is, these generators are not heavy in weights, they are very portable. So you can easily install it, relocate it, reinstall it, very light in weight and easy to install. Next slide, please. So in conclusion, what I mean to say that is this hydrogen generator is a very reliable technology and economical technology, which can serve to sustain this industry from this competitive age. Because as you know, everybody, that today we are in the era of very cost competitive. So with this technology or this heating source, we can be a cost competitive. Our brazing component can be a cost competitive. Then this is from the safety point of view, there is no flashback. So operator safety is taken into consideration. As I said, it has produced a very uniform temperature, and the flame temperature is around 2700 degrees centigrade. The operation and the flame is very silent, and so the noise pollution also is less compared to the conventional flame techniques, which are the gas techniques which we are used for the brazing. As I said, for the power source, it is easily available. The generators are working on 230 to 40 volt power supply and can produce 1.5 to 15 liters per minute. Gas is being generated. The running cost is very low, and cost for the maintaining also is very low. The running cost is the cost of the distilled water and the power required for generating the gas for the electrolysis, basically, not for the electrolysis. And as I said, it is suitable for brazing numerous brazing applications, or we can be braze numerous materials. Thank you.
Thank you very much, Dr. Manishi. Now, can I invite Arun Kumar Sharma ji, otherwise Richard Puraka, for their presentation, please?
Thank you, Samanji. Actually, in our presentation, we will discuss more about the solutions or product which is already available in the market to overcome this unavailability of the oxygen. Also, we have put all the queries or all the questions from the technicians from both department for the residential air condition, as well as we have covered the commercial air condition. In our first slide, we have mentioned for the successful brazing, what we required. We have to flow the nitrogen while we will do the proper brazing. Next, please. To flow the nitrogen is not the sufficient. We have to know what pressure we have to flow, what pressure of nitrogen we have to flow while brazing process. So there is a lot of products already available in the market, like nitrogen flow indicator, NitroView. I think Mr. Richard will give some more ideas about such products. So Mr. Richard.
Thank you, and I just want to appreciate the invite to be among such distinguished organization and guests. It's a pleasure to see you all, and definitely this is an important topic on brazing. There are so many methods. I just want to express that definitely one always must evaluate their specific need, their specific requirements. As Mr. Bernardi mentioned, with the air fuel or air acetylene torches in the United States, that is a very common usage, but not so much in the rest of the world. And there are reasons for that. Number one, it's unknown. And number two, many times the technology in air fuel torch is also unknown. And so lesser designs and technology are introduced in the market. They don't work and people don't use them. But in the United States, it's been a proven technology for quite some time. And the air fuel systems, what they allow you to do is, particularly in HVAC applications, at least most technicians have a limited range of sizes of copper tubes, for example, that they're working with. So the air fuel solution for them is fantastic. It's an excellent solution because they don't need a variety of diameters to braze of copper tubes. Now, a technician that has a variety of sizes and types of tubes that they're dealing with, perhaps then an oxy-fuel system might be best for them. So there are lots of pluses and minuses as to why you might go one way or the other. But in general, in HVAC, most applications, most technishans will be satisfied with an air fuel, air acetylene, precisely, will do the job for them. And as Arun mentioned, basically, we want to ensure, we'd like to think of brazing as the heart of the refrigeration system, because if you don't get that right, then you're going to have failure. You're going to have inefficiencies in the systems. You're going to have your expansion valves that get contaminated with soot and with copper oxide from that forms on the outside can also form on the inside. That's why when we talk about running nitrogen through there, we have to make sure we're always running nitrogen to avoid forming that copper oxide inside, so that it doesn't contaminate the expansion valves, it doesn't run to the compressors to damage the systems. So the proper flow of that is also very important, because if you don't have enough nitrogen flowing through the inner tubes to displace the oxygen in there, which forms that copper oxide with the heat, then you're still going to have it formed. So you want to have the correct flow, and you also don't want to have too much flow, because then that will push against the joint, and then you end up having little pinholes and you have refrigerant leaks. So it's very important always to get the correct braze job. Limitation, I'm not sure how many more slides we have here, but I do want to express that as great as the air fuel systems are, air acetylene systems are, there are a few limitations. One of them is the supply of oxygen. Again, we are using oxygen. We're using oxygen from our ambient air that's mixing with the fuel, whether it's LP or whether it's acetylene or MAP or some other fuel gas, but we are taking oxygen from the ambient air. So if you're in a very high altitude, you may not have enough oxygen. If you're in a very enclosed quarter, in a small area, there may not be enough oxygen to mix. So these are some considerations to take into place. But overall, the air acetylene, for example, here in the US, very widely known, and as Mr. Bernardi had mentioned, very low cost operation as well. You use one tank, a lot more portable to get from one place to another, and it just provides the solution. And finally, I just want to mention that, you know, when we're faced with challenges as we are now during the pandemic, and the world is faced with so many different challenges in so many different areas, we're living that now. It's just a reminder that always we must be preparing. And I think it is awesome that an organization like RANA provides this knowledge base throughout the year. So I just say, you know, take advantage of that and learn, and don't wait for a crisis to come to know about these technologies. Be prepared. And it's just always a great time to sharpen one's skills. And I thank you for having me, and a pleasure seeing everybody.
Yeah, so these are some frequent questions which technicians ask. Is butane is small cylinder is the right solution for the copper brazing? How can we avoid to carry two setup cylinder for the service call? Is it possible to braze with LPG without oxygen? Is it possible to braze bigger size pipe up to 3 inches with acetyl without oxygen? Or is a special torch which gives a wrap round heat to bigger size copper pipes for uniform brazing? So next slide, please. So here we have mentioned some limitation of the butane. Butane will not evaporate at lower temperature, so the torches will not work at the cold temperature. It is difficult to achieve the required temperature for capillary reaction for brazing process. We will just show the video later on about what is the capillary reaction, why we need the capillary reaction for the successful brazing. And it takes longer time to braze the pipe, which allow more carbon inside and outside due to the oxidation process. Brazing limitation is up to 5.8. No safety valve inside these butane cans, and sometimes what happens when technicians do the brazing to the refrigeration, it has to tilt the cylinder. So sometimes what happens is stop working, or may it give the big fire. So these are some limitation of the butane. So next slide, please. So here's the solution, the propylene gas, which is already available in the market for last 3 to 4 years, and a lot of big corporates like LG, Mitsubishi, IFB, they are promoting, and they are just doing marketing, and they are pushing the technician to use the propylene gas instead of butane. So here is the flame temperature, which Mr. Garville already mentioned. What is the temperature range of methyl ester propadiene? So it has a inbuilt safety valve or pressure relief valve inside the cylinder. So the technician safety should be the first priority for our industry. So it is very portable. The net weight of the cylinder, including the gas, is not more than 800. this fuel burn approximately 40% hotter than the propane. This allows user to carry out the hotter working tasks without need of any oxy LPG. And third one, special torches are available in the market for propane, which can raise up to 2-inch pipe without oxygen. So this is also very good to tell to my technicians. Special torches with 360 degrees swell up to, which can operate in any position. So this is the solution for regarding that problem in the butane. You cannot peel the butane. So here you can just swell 360 degree. Next slide, please. So Mr. Richard, so from here you have to go forward.
Oh, excuse me. I have to do a PowerPoint from here,
Yeah, from here should be.
but I don't know if we have the video incorporated in there.
It's already incorporated in the last slide. I think Mr. Samant already incorporated the videos.
You want me to start the video? I will just try it again. But if you finish the slide and you can do the video, that will be better, because then there won't be any. I don't have to wait again. Then.
Yes,
You can go ahead from here.
If we can do the capillary action, this is the key function in brazing. A lot of times when we're brazing, particularly when it's in a system and we're out in the field, we're using a mirror to see the side of the copper tube that is not visible to us, to see if the alloy has run around and run through the joint. So that's fine that you might see it on the outside of the copper tube, but it's very important that alloy penetrate the union of the copper tube. That's where you actually form the strong braze, because if you don't have that penetration with capillary action, basically what is going to happen, you're going to have a weak joint. And when you have a weak joint, any vibration is going to loosen that, and you end up with refrigerant leaks, which are very costly. So we use these.
Variation in spacing will affect the success of your brazing operation, because capillarity will be compromised.
So basically,
second, cleanliness counts in brazing. Parts that are not properly cleaned may carry grease or other debris, which will impede the process of capillarity. Successful capillary action, the process that allows alloys to flow into the joint between two metal parts, is crucial to successful brazing.
Okay, that got cut short, a little short. What that video part of the video shows is two glass plates, and it shows ink running between the two glass plates through capillary action. Now, when you have a separation, when it's wider on the bottom than on the top, that ink does not flow through all the way to the top. Similar thing with a copper tube. If your spacing is not, if the diameters are not evenly spaced from the one that's being inserted into the other, you're not going to be able to form great capillary action and run the alloy through. So you want to make sure that you do get a good braze joint by having proper heat around the entire tube. It's important not just to fill the alloy around on the top, but it needs to penetrate that copper tube.
Next slide, please. So this is the answer of the technician's second last question, whether is it possible with LPG or with ethylene without oxygen. So we have a already special torches available in the market, which is called the swell combustion torches. So these swell combustion torches flame work 40% hotter than the other air fuel torches. It is completely burns the fuel inside the flame tube, creating the stable blow resistance flame. The high velocity clockwise swelling flame has a wrap around effect with no feather. Higher velocity flame transfer heat better and minimize the cooling effect of the ambient air. So better heat transfers to the target, decrease the labor time and also the fuel cost. Just next slide, please. So these are some torches available in the market. These are the air LPG torches. So with the LPG, we can braze up to 114, and with propylene we can braze up to 2-inch pipe with the same torches. Next slide, please. These are some torches, well torches, which work with the air and acetylene. And with acetylene, we can braze up to 4-inch pipe without using the oxygens. So these are some specifications we have mentioned in this slide. So next slide. Actually, the last question from the technician: is it possible to braze the bigger size pipe giving the 360-degree heat? So we have just mentioned one video there. I think where is the video that Samanji? That is Captain Hook video. Mr. Richard will explain about this video more.
Take a look at the performance of a single flame tip versus Uniwell's MTF5 multi-flame tip. With single flame tips, one must ensure to move the tip around the copper tube to achieve good heat distribution. With today's compact systems, this can be very difficult to achieve, particularly on the backside of the copper tube. Uniwell's MTF5 Captain Hook multi-flame tip, shown on the right, provides even heat distribution around the 360 degrees of the copper tube. In addition to providing 100% wraparound heat, the 40-degree flame angle easily flows onto the copper tube and away from sensitive areas, thus minimizing the chances of burning adjacent components. Uniwell, quality tools that go to work with you.
So cleanliness of the tube, the proper size diameter, that it's uniform through the 360 degrees of the copper tube, and the uniform heat, the proper heating that you get around the entire copper tube, that ensures that you get the capillary action that is required to have that strong brazing joint, so that you don't have leaks with minor vibrations, and you have a good, healthy system.
Thank you very much, Samanji. Thanks to everybody.
Thank you very much. I will try to see the other YouTube videos if that is possible, just to give the idea. This is the one which is this was with the hydro torch. This is what is called as the pencil torch. It's just the comparisons between the torches. And this is your standard torch, which is oxyacetylene. So I think the presentation is over. Now we can go for any kind of question answer.
Sumanji, there are a couple of questions which are there in the chat, which says there is one question from Mr. Dinesh Sarova, which says I think what he's asking is what is better for copper to MS braiding? Oh, yeah. What kind of brazing is better for copper to MS? I'm assuming that's his question.
Yeah, can I ask Gabriel to answer this, please? You want to answer this?
Madhuriji, I'll answer the question. I think Gabriel.
Sure.
Yeah. So basically, for copper to MS brazing, if you are using an air fuel torch, then you also need to see air acetylene torch would be a better option. obviously the diameter of your pipe and the thickness of the pipe that you're brazing will matter. It will be slower than your oxy-fuel process, as already discussed. But also very important is the brazing alloy that you use. So if you're brazing it with a brass brazing alloy, then it's going to be a little more difficult. But if you use a high silver brazing alloy, that would be better for your application. So proper application of the flux and using an air acetylene torch, you should be able to braze your joint based on the thickness of your base metal.
Great. Prabhav, another question is thickness range can be, what is the thickness range that can be brazed for copper to copper by using fuel LPG and acetylene?
Right. So we've faced the same question since the last couple of weeks, couple of a month and a half rather now. But the main idea is again, it will depend on the diameter of your pipe, what gas you're using. So you need to use an air acetylene torch, and you probably go up to easily. You should be able to do it with up to 1 inch dia pipe. 1.5 inch, somewhere around that.
There is another question in the chat by Mr. Mahesh Rajwade. Can we use cap and hook with MAP gas?
Yes, he can use, but again, he has to use for the cap and hook, he has to use the oxygen. So this is the limitation of cap and hook. And up to 3-inch pipe, we can braze with cap and hook.
Okay, I have one question. I mean, quite a few of you are aware that, I mean, we are into manufacturing of heat exchanger and we require continuous use of oxygen and acetylene. What are these alternative methods which have been suggested by you, which is the most for continuous assembly line?
If I can just say some of the things in continuous assembly line, if you go for kind of a water designated with the gas, it is normally these kind of machines, they can provide 24 hours solution. Because in continuous gas line, normally the problem is that your LPG or your fuel, if you are trying to do it with the air, then the ratio becomes too high. And in continuous, it is observed actually that the air to air, the burning with air normally should be done in a well ventilated area. Because when you burn with oxygen, you get 100% combustion. But when you do with the air, normally the air quality decreases after 24 hours. And these are the scientific findings in the journals also. The wire, the air quality decreases to some extent. So the technology wise, you should go for something which is non-polluting when you are talking about the continuous operation, and that can be provided with water gases. Otherwise, as I suggested, if you are not in position to use the gases, and if you can go for some alternate method like induction or resistance or something like that, then that can be one of the solution. But I think if Mr. Shekhani wants to add on to it or say something about it.
I think for heat exchanger manufacturing under current situation where oxygen availability is an issue, so you have an alternate by using a air fuel torch, and there are some other processes which has been established, that is with the compressed air and LPG. And for heat exchanger application, the application what we are talking about, copper to copper brazing, it works very fine. But that is for continuous production. But these air acetylene torches are good for field application as well. You know, when you're installing bigger size of air conditioners, those are better for those kind of application. So current situation, yes, you can actually look at compressed air or fuel torches, compressed air fuel torches, and there you can do almost most of the brazing up jobs which you are doing at your factory right now.
Thank you. Thank you for that answer. Oh, there are quite a few questions which have come in. What is the best ratio of brazing in compressed air LPG brazing operation?
Normally 2:7 should be the right ratio.
Okay. There is question.
And 7 of air.
Okay.
The only thing when breathing with compressed air and LPG, the only thing is the initial ignition needs some patience. That may take some time and adjusting the air pressure and what Samantha sir is saying, that we need to adjust and get the right ignition and right flame at the top.
Great. There is question by Mr. Durai Murugan. It says, shall we use brazed copper pipe with SS316 grade material? I did not get the question. Brazed copper pipe with SS. I think what perhaps he is asking is, through this method, can they do the brazing of copper and SS316? I think that I'm assuming that is his question.
Can you repeat what is the question you said?
His exact question is, shall we use brazed copper pipe with SS316?
It may be other way around. Like, can we braze the copper pipe with SS316? Yeah, they can braze, but you cannot use copper phosphorus brazing alloy. You need to use silver brazing alloy basically, or alloy without phosphorus basically.
Alloy without phosphorus with nickel content preferably.
Yeah, correct.
Right. There is another question which says, which torch is recommended to do brazing of heat transfer coils using compressed air and LPG fuel? This question is by Mr. Manoj Gandhi.
Yeah, I think there are specific torches available, and those are basically designed for air fuel, because air fuel, as you said, the ratios are different from normal oxy fuel torches. So these are specifically designed torches which are available.
Great. I think we have covered all the questions. Guys, anyone has got any further questions? Feel free to
Sir, I have one question.
Yeah.
Hello, am I audible?
Yeah.
Who's this?
Yes.
It's Dinesh.
Yeah, Dinesh, go ahead. Yeah.
Sir, what we have done, we have tried brazing with compressed air in our operations. Hello.
Yeah, we can hear you.
Yeah, go ahead.
So the problem we are facing now is with copper to MS. We got success with copper to copper. We got success with copper to brass also. But we are facing problem with copper to MS during this compressed air brazing operation.
Yeah.
So can we suggest what is the alternative, or what should be the ratio? Can we increase the ratio of air, compressed air, to do that?
Compressed air LPG for steel to copper brazing will be little difficult. You may need to look at compressed air with acetylene to braze these steel to copper joints.
If anyone wants to add something in this.
I'm Jaspreet here. I have a small question. In brazing, when you start brazing, usually when you ignite the torch, it has a yellow and a blue flame. So when you use a torch which has no oxygen inside, how do you control that?
I'll answer your question. Are you talking about air fuel torches, or are you talking about compressed air torches?
Air fuel torches.
Air fuel torches, you do not need to control the flame. You need to keep the walls on completely. The walls need to be completely open, so the torch manages its own ratios. You don't have to do anything about it.
Thank you.
Yeah, sorry. There is a question by Mr. Parulekar. He's asking, can we use oxygen concentrator and use oxyacetylene flame instead of air acetylene?
Yeah, it can be done like that, but after using oxygen concentrator, if he's talking about oxygen concentrator, which is a small kind of oxygen concentrator, then he needs to have it stored and compressed and then given to the line in order to get the pressure, because otherwise just oxygen concentrator will not give enough pressure for the torch, because the pressure becomes one of the criteria in burning of the torch.
I think maybe 15 to 20 liters of oxygen concentrator is required. a normal oxygen concentrator of 5-liter capacity or 10-liter capacity won't work. That is what I feel.
Yes, you are right.
Normally, these oxygen concentrators are not used for this application. So you will not get the oxygen pressure as Mr. Samantha said. Yes.
Yeah, I mean this is basically for the smaller jobs. You know, you do it for a few minutes or something like that. It is not a continuous job anyway.
Yeah.
It will look like that.
I would like to interject just basically. I know there were questions about brazing with different types of application, different types of steel. And just keep in mind that, again, when you have the air acetylene torch that's using the oxygen from the ambient air, you're getting approximately 1500 degrees centigrade of heat on your output. So it's always just important to know also the application point of the alloy that you're using. And if that application point of the alloy falls within those parameters of the heat that's being produced, you're more than likely going to be all right, that you can at least heat up the steel with the copper. But with air fuel or air acetylene, it can take time. Depends on the thickness of the stainless steel, for example. But it can be done. It just depends on the alloy you're using as well. So there are a lot of variables to take into consideration. But and just one thing I want to point out is with the air acetylene torches, as has already been mentioned, yeah, your pressures are set. It's not like with oxy fuel, and we have to remember that when we're switching from one technology to another, our habits sometimes interfere with the operation of the new technology that we're using, or different technology. So where in oxyacetylene, for example, or oxy LP, you have to be very mindful of the pressures that you're using with the oxygen pressure and with your fuel pressure or acetylene pressure. With air acetylene, that's not a concern. One less thing you have to worry about, because that is automatically set already by the orifice on the tip that is being used, and the mixture that it's using from the ambient air, from the oxygen.
Oh, right, Pritesh bhai, I think we can conclude. I think there are no further questions.
So,
Pritesh, I just want to ask one question at the end.
Please.
I didn't ask any question because it was looking like, such a technical program that we've had on the Rata platform today, when we've been used to having, so many commercial side of programs. So it's just extremely heartening to see how people have been, trying to learn and share information technically on this platform. Hence, I didn't ask my question. I've left it for the last. My question is that, as per our regular oxygen-based brazing torches that are there, and today when we are talking about alternate methods, so maybe air acetylene or fuel, is this a long-term solution, or is this just a solution when there's a shortage of oxygen? So I just want to understand, does one invest in this long-term, or is it just a discussion today?
I would like to answer that in just simply, it's a great question. It's coming as a result that you're being introduced to this as a result of the challenges that are faced in the market now. But understand that it is a technology that's widely used. It's very common, for example, in the United States. It's been around for decades, and the benefits of that, again, if depending on your application, if it's not very varied, if you're working within certain limitations on diameters of copper tubes, it's just nice to be able to worry about one pressurized gas, which is your acetylene. It's a lighter load. It's more transportable. Better in terms of safety. You don't have to worry about gases coming back to the tank and mixing the oxygen with the acetylene when you have improper pressures set, or when you're touching the brazing tip onto the metal accidentally. You get those back pressures and flashbacks. that's practically eliminated with an air acetylene. So it is a technology that's here to stay. I think a lot of people that it's to stay in India. It certainly is used a lot in the United States. And as people get introduced to that and get accustomed to working with that, they're going to see the benefits of that and how it can actually aid them in their operations to be more efficient. And actually, if you're using oxygen acetylene now, you're going to be able to eliminate that cost of the oxygen refill and actually cut that cost also. So a lot of benefits to be made, and definitely it's a technology that's here to stay, no question about it.
Mr. Mathuraji, you will like to add something?
Yeah,
Zakhani.
Yeah, Richard, I feel that what you said, it is being used widely in the US market, and we've been trying to introduce this in the Indian market, and because of the pandemic and oxygen shortage, we're talking about this, but then this is a technology which is good for actually the installation field and other challenges, as Richard said, that diameter of tubes, and under particular limitation, it's a technology which is going to be there, stay there. And I think if we work together, we can get these technologies which are being used widely in other parts of the world, introduce here and use them more widely. So that I think it is a good question, Akash. I think we will have more technologies which are there being introduced in India, and we'll work together to see that this is promoted well and used well in the industry.
Prakashi, it is said that, in adversity, you always find an opportunity, and necessity is mother of all invention. Yeah. Surprisingly, here the invention is already there. The necessity has come now. So I remember I had seen this technology way back in somewhere around 2008 or 2009. And I mean, I know a couple of you have been, I think, reaching out to me, but today under the current scenario where we are seeing that, this particular oxygen can be used to save someone's life, that is the time now we are getting open to this kind of technology. I mean, I'll raise my hand and say that perhaps I was guilty of not using this kind of technologies which were available in the market, But now, I mean, adversity has actually brought us to go towards these kind of technologies. So thank you guys. I think you guys have been getting this technology since ages, I think years together, which have been available in Indian market. It is just because of the oxygen shortage now that, I mean, our eyes are opening towards it.
Manishji, and Mathuraji, would you like to add something on this?
No, I think it's everybody has said something. So yeah, but it is always there. Like it's a necessity is the mother of invention. So we should why should not adopt something which is new and good for everybody.
Mr. Manish Samani, a parting note on this.
Yes, it's good that one should look for such technologies which can be always be in your handy, so you can easily replace and your production cannot get hampered. So it's good to have this type of technology to be known.
Thank you, sir. Manish Kulkarni. Manish bhai.
Manish Kulkarni. Manish.
So I think we are almost through now, and we can go for the final listing, because more or less everyone has concluded in the best possible manner, and I think we can go ahead in future without oxygen. That is what I can see.
So I just request Ms. Jaspreet Singh Sethi, Vice President RRC Mumbai, to just vote of thanks.
Thank you, Pritesh bhai. It is my great honor, and I would like to thank each and every panelist who has taken his precious time out, especially Mr. Richard and Mr. Gabriel, seeing the time difference from where they are and we in India, have taken the precious time out, got up early and given us this beautiful presentation. Somanji, Arun sir, Manish bhai, as well as Mr. Prakash Sakhani, thank you so much for coordinating with Mr. Gabriel and Mr. Richard to get this beautiful presentation in this time. This pandemic has really taught us how to go back to our studies, go back to what we learned in our engineering courses, and look up for new changes which we would like to bring to our new businesses as well as production houses, which will definitely help us. I would like to thank our India team, Mr. Mihir Sangvi, Akash Verma, Pritish Bhai, Prakash Sikhani ji, as well as Manish Kulkarni ji, who've taken a lot of efforts to get this show together. Back office team, Ninad ji, Savita and Vishakha. And I would like all those people, all those delegates who attended today, who are not members of RATA, to please join RATA, and we would love to bring such technical as well as commercial programs for you, which will help all of us grow together. Thank you so much.
Take just one thing. We like to thank RRC Mumbai chapter President Mr. Amod Dixit for helping us in this seminar.
Yes, Pramod ji, Amod sir, thank you so much for helping out and putting up all the points together. Thank you so much.
Samir bhai.
Yeah, thank you, Jaspreet ji. And guys, I mean, when you have this kind of panel in front of you, you know, you're always going to be more greedy. So I think it's a humble request to each one of you. We would love to have you guys again once more after a month or so, where we can, you know, again address, you know, brazing is one of the most integral part of air conditioning and refrigeration industry. And, you know, we can come up with, I think, let it be towards the basics also, the right kind of usage of torches, the right kind of usage of, you know, brazing methods or wheat alloys, what we are using. I think, you know, this is something need of the hour. It will not only help, you know, business, but it will also help the trade as well as this world, you know. I mean, the amount of refrigerant what we are losing out. I mean, yesterday we were discussing on the mock trial, and I remember Prakash ji making this point that internationally, when you lose, you know, refrigerant gas into the, you know, atmosphere, it is mandatory to actually reach out to the government, and I think, you know, and it's an punishable offense. Unfortunately, so far we have in India we have not been that particularly, you know, how do I say, very sensitive towards it, and this is something we guys have to start looking at it. Today, just lack of oxygen has made us start running around looking towards this innovative products. I hope that tomorrow, I mean, a bigger hole in ozone should not lead us to, you know, run around for other products to get saved from that. So I really hope that I think we move to the right kind of technologies. And seriously, guys, this is a dream team, dream panel. I have learned so much, I mean, today from each one of you. And yes, team of Prakash Sekhani ji, Pritesh Bhai and Manish Gulalkari ji, ye dil mange more. It is not going to stop here. I think we require more these kind of programs. And thank you so much, Richard and Gabriel, for joining us. And absolutely a very early morning it is there for you guys. And Manish Samanji, thank you so much. Suman Mathuriji, my go-to man. Whenever I'm in any trouble, I think I always reach out to him. Prakash ji and Prabhav, man, I am impressed with you today. Seriously, the kind of knowledge what you have, this is outstanding. And also, Arunji, thank you so much for the inputs what you guys have given. This is learning for everyone, and we could see that you know, the amount of mails what we have received that they could not attend this particular webinar because of you know, maximum limit what we reach. So friends, don't worry, this webinar is got recorded, and we would be putting it on the YouTube as well as on Facebook, so you can go through that. And of course, yes, we'll have shortly another version of this particular webinar. Thank you. I think kudos to each one of you.
Mihir, are you saying that we have done today's seminar before the sales, and after 1 month we will do it after sales, so everyone can buy it and then we can do a practical?
Yes, absolutely. People will fill up the product now. Understand the technology.
We are in pandemic times, so season 2 is awaited now.
Awaited, yeah.
Absolutely.
And we assure you that. We assure everyone.
So we look forward to the trade to support this entire cause. I think this is something that makes sense to do a second, you know, part or addition to this after a person has actually used it, because then you come up with more practical issues that can be. And let's make this a long-term sustainable technology. Yeah, Mihir, we want to make it a long-term sustainable technology. So we have to learn. We'll never become experts until we try it ourselves. So Thank you. Thanks, Mihir.
I think, Akash, we have Mr. Deepak Dalmia who is here. I think our dear friend, and I think I'm seeing him after a long time. Deepakji, if you don't mind, can you switch on your video? And we would like to hear from you. Here comes our dashing Deepak Dalmia. So good to see you.
Yeah, hi, good evening, everyone. I, in fact, heard very carefully the entire seminar, learned a lot, made some notes also. And certainly we'll contact people and try to, even we make condenser evaporators and we are into installation and commissioning and all. So this challenge is there. Somehow we are making good with the conventional torches which are available with butane and even propylene gas. But a long-term solution which light has been shown today, we'll explore and try to take it forward and on a sustainable, on a continuous basis. Really an interesting seminar. Thanks Rata, thanks Ishre, and thanks whoever, all the people who are involved in, bringing it to the people of the trade. It is a very beneficial, endeavor which Rata is doing. Great.
Thank you, Deepak, for your kind words. Really means a lot. Great.
So,
yeah, Pritesh bhai, please go ahead.
So please, thank you very much, thank you everyone for being here and for support. And we'll surely come up with the second version of this after a month or so. Thank you very much.
Thank you, guys.
Yeah.
Thank you.
Thank you.
Thank you.
Thank you, everybody.
Thank you.
Thank you. Good day.
Good day.
Savita, you can stop recording it, please.
Yeah.